Okay, this is our lesson on solving one variable quadratic equations. This is going to be our second method. This method we'll call isolating the variable. Our first method was solving quadratic equations by factoring and using the zero product property. This lesson in Eureka has a bunch of word problems, which we'll do later, but today we're just going to concentrate on the skill of solving the quadratic equations. For this first example on page 28, we can actually look at two different ways of solving it. Okay, so the equation is negative 16t squared plus 4 equals 0. Now what I want to do is I want to isolate the variable. And since this says t squared times negative 16 plus 4, the first thing I'll do is I will eliminate the plus 4 by subtracting 4 to both sides, and I will get this equation. And then I'm going to divide both sides by negative 16, and that will give me t squared equals positive 1/4. Now all I have to do is get rid of this square function, and to do that I'm going to use the inverse of squaring, which would be square rooting. So I take the square root of both sides, so I end up with t equals the positive and negative square root of 1/4. The square root of 1/4 is 1/2. So my solution is t equals positive or negative 1/2. I can write it like that, or I can write it as a solution set as negative 1/2 and 1/2. And remember, when you write it as a solution set, you write it in numerical order. The second method here, which was actually our first method, was to solve by factoring and then to use the zero product property. So go ahead and press pause and just look over this, because this is something you should be totally familiar with. Okay, actually, that little bottom part was cut off, so the solution is actually t equals negative 1/2 or 1/2. Right now, we're just going to go through these four examples. I'm going to solve each one of these by by isolating the variable, and notice some of them may have radicals in their solutions. In this case, they're going to be square roots. So this, number one, is x squared times 3 minus 9. Therefore, I'm going to get rid of the minus 9 first by adding 9. I'll get 3x squared equals 9. Now it's just x squared times 3, so I'll get rid of the times 3 by dividing by 3. And now I can undo or get rid of the squared by doing the inverse, square root. So if I take the square root of both sides of this equation, I will get x equals the positive and negative square root of 3. The square root of 3 is some irrational number, so instead of giving a messy irrational number, we will just leave our answer in this radical form. Now on to number 2. This has x minus 3 squared. So going the inverse order of operations, I'm going to get rid of the square first by taking the square root of both sides. Take the square root of both sides. I'll get x minus 3 is equal to the positive and negative square root of 1. I believe the square root of 1 equals 1. So now I will add 3 to both sides. And so my solution is, well, let's see. When x is 1, 1 plus 3 is 4. Or when x is negative 1, negative 1 plus 3 is 2. So my solution is 4 or 2. I can also write it as a solution set in numerical order like this. Either way is acceptable. Okay, the way that Eureka had this number 3 was pretty much the same as the other one, with a slight difference. So I'll do this one a little different. This is x minus 3 squared, so I get rid of the squared first by taking the square root of both sides. So I can end up with x minus 3 equals the positive and negative square root of 17, which is an irrational number, so I can leave it in radical form. Then I would add 3 to both sides. So my solution is x equals positive and negative square root of 17 plus 3, which is a perfectly fine way of writing the solution. Or you can write it like negative square root of 17 plus 3 and positive 17 square root of 17 plus 3. I'm sorry, my pen is messing up pretty bad. It's not my fault. Moving on to number 4, we have x minus 3 squared and then times 2. So I'll get rid of the times 2 first by dividing both sides of the equation by 2 and get x minus 3 squared equals 6. Now I'll take the square root of both sides because that's what's next. I get x minus 3 equals the positive and negative square root of 6, which is again is irrational, so I can leave it in radical form. Finally, add 3 to both sides and get positive and negative square root of 6 plus 3, which is okay to write it. Now again, keep in mind, if it had been something like x is equal to the positive and negative square root of 16 plus 3, then you would have said that is equal to positive and negative 4 plus 3, which you'd have to actually work out and say, well, 4 plus 3 is 7, or negative 4 plus 3 is negative 1. You'd have to actually work it like that. You could not leave the answer like this. Okay, so here are a few more examples. I'll do them pretty quickly. Now keep in mind, this isolating the variable is just one method. A few of these you could probably do by the other method, the factoring method. Okay, so let's just look at number 2. Number 2, I can divide both sides by 4 and get x squared equals 9 fourths. And then take the square root of both sides. I get x equals the positive negative square root of 9 fourths. Well, it turns out the square root of 9 fourths is actually pretty easy. That is 3 halves, also known as 1 1/2. So my solutions are positive and negative 1 1/2. Now you will notice that I could also have worked this another method. I could have set this equal to 0 by subtracting 9 from both sides. This is a difference of squares, so I could have factored it. We got 2x plus 3 times 2x minus 3 equals 0. So my solution will be, what makes these 0? Well, 2x plus 3 equals 0. And x equals negative 3 halves or negative 1 1/2, just like before, and this would give you the positive 1 1/2. So again, sorry about the pen. Number 3, I'm going to go ahead and isolate the variable. I'm going to add 8 to both sides and get 3y squared equals 21. Next, I will divide both sides by 3 and get y squared equals 7. Take the square root of both sides, I get y equals the positive and negative square root of 7. Para número 4 es d a 4 squared. Oh wait, let's see, we're going to get rid of the square first. Take the square root of both sides, we'll get d plus 4 equals the positive and negative square root of 5. Then I will subtract 4 from both sides and get d equals positive and negative square root of 5 minus 4, which are my two solutions. Number 5, let's see, I got to figure out what order to go in if I'm going to isolate the variable. It's g minus 1 squared plus 4 plus 6. So the plus 6 is what I'll get rid of first. So I get 4g minus 1 quantity squared equals 7. Divide both sides by 4, I'll get g minus 1 quantity squared equals 7 fourths. Take the square root of both sides, I'll get g minus 1 equals the positive negative square root of 7 fourths, which actually is equal to positive negative square root of 7 over 2, because we can take the square root of 4 and get 2. Now I'll add 1 to both sides and get g equals positive and negative square root of 7 over 2 plus 1, and that's as far as I can go, so this is my solution. For number 6, I saw it was a k, and then I took the opposite of that, and then I added 5, then squared it, then multiplied by negative 2, and then added 20. So the first thing I have to do is get rid of the plus 20, so I'm going to subtract 20 from both sides, and I'll get this equation. Notice I changed minus k to be plus the opposite of k, just to be safe. So next, looks like I'll have to divide both sides by negative 2, and get positive 4 equals 5 plus the opposite of k quantity squared. Now I'll take the square root of both sides and get the positive and negative 2, that's the square root of 4, is equal to 5 plus the opposite of k. Subtract 5 from both sides, and I will get, let's see, 2 minus 5 is negative 3, and then negative 2 minus 5 is negative 7. I get both of those solutions. But I still have this opposite sign in front of the k. So if the opposite of k is negative 3, k must be equal to 3. Or if the opposite of k is negative 7, k must be 7. So my solution is k equals 3 or 7. Now for your assignment tonight, you're going to download the worksheet that says factoring quadratics by two methods. You can solve several of them by factoring in the zero property. That's what we learned in the other classes. Or you can solve some of them this method. You pretty much have to look at each one and decide what would work best for you. So download that and work hard. Goodbye.